Okay, class. Today we're going to go through section 3.3, page 112. The title of this section is called Measures of Relative Standing. This is the last section before we can begin to test you on all the material from chapters 1 through 6. So this is the last section. Okay, so measures of relative standing. So if we were to conduct a measurement of our heights. So let's say that we measure all of the students in our class, our heights, and we record who's the tallest and who's the shortest. And then we would compare ourselves to the San Antonio Spurs. Well, their tall is way much higher than ours. And probably their smallest person will probably be our tallest person in our class. So we need to devise a scale so that way we can measure our heights to be standardized. We can't just say that our tall person is really the tallest person because there's more people that are taller. So relatively speaking, in our class, the tallest person will be the tallest person, but just only in our class. But if you compare that with the overall total people in the population, whether it's in the United States or the world, our tall is probably not going to be the tall. So that's why we develop a scale. And the scale that we use to standardize things like heights is what we call a z-score. So a z-score is found by converting a value to a standardized scale as given in the following definition. So the definition shows, this definition shows that a z-score is the number of standard deviations that a data value is away from the mean. And so there's a formula that we use to standardize it. Right? So here's the definition. Again, a z-score, standardized value is the number of standard deviations that a given value x is above or below what the mean is. So there's two versions of the formula. So if you are using a sample, the sample formula is z equals x minus mu, x minus x bar, x minus x bar over s. So sample, remember that is your sample mean, and the s is your sample standard deviation. Or you all can use the formula for the population. So z equals x minus mu over sigma. Recall that mu referred to the mean of the population, and the curly O, the sigma, represents the standard deviation for the population. Now, what I usually do is I enclose the numerators, the top part of the formula, in parentheses, so that way you won't get confused. The top has to be done first, and then divided by the standard deviation. So there's the two formulas. So it doesn't matter which one you use, you'll end up with the same answer. And remember that there is a round off rule for this one. This one says you have to round to 2 decimal places behind the decimal. So that would be the hundredths. You gotta round it off to the hundredths. For any of those two formulas. All right, so here's a scale that we are going to use. Let me put the formula that I tell my students to use. So for the sample, z is equal to x minus x bar over s. Population, z equals x minus mu over sigma, and round to the hundredths. Round to the hundredths. Right? So we're going to have the scale. So the scale that we use looks like this. So kind of like the number line, right? And in the number line, recall that in a number line you have 0, and then we number it 1, 2, 3, 4, and so forth, right? And then likewise go backwards, -1, -2, -3, -4, and so on. So this scale is broken off into pieces. So you have the cutoff scores is from -2 to +2. So it's kind of like the material that we covered in the end of 3.2, where we did the usual, the range rule of thumb, the usual, unusual. It's kind of like it. But this time you are dealing with either one of those two formulas. It doesn't matter. Whatever number that you get, you're going to plot it. And if the value of the z falls in between -2 or +2, we say it is usual. If it falls above 2 or below -2, we say that it is unusual. Okay. So you're gonna ask me, well, sir, what if the z actually is exactly at 2 or -2? Where does it belong if it falls right in the middle? If it falls right in the middle, right on that edge, it would be considered usual. If your answer ends up being 2 or -2, right on the dot, you consider it unusual. You consider it usual. All right, so we use this a lot to standardize things. So let's think of some examples. So if we were measuring heights like we talked about, do you recall a basketball player by the name of Yao Ming? Yao Ming used to play for the Houston Rockets. He was tall. Where would he be at in terms of heights in our scale? Would he be over here or over here? Correct. His height is extremely tall, so he would really go way, way, way over here, far at the end, left, right side, right? Way at the right side. He would be that tall compared to other people, right? Heights, all the men's, right? So he would be on the far right end. Now, do you recall by the actor by the name of Danny DeVito? Danny DeVito was the original Penguin in the Batman movies. He's short. So where would he be at? Correct. He would be at the far extreme left, way over here, close to Hobbit, right? Way over here. So you have the extreme. So the shortest people on the far left, unusual, the negative unusual, tall people way above, right? Way above on the far right. All right. So let's do an example. So I looked up the average men's heights, and I looked up the average women's heights. So the mean for the men height, female height. The mean was for the males 163.85 centimeters. And the standard deviation for males was 6.35 centimeters. Now remember, in the medical field, we record our measurements in centimeters. All right, for females, the mean was 161.29 centimeters. And the standard deviation was 6.35 centimeters. Okay. All right, so it's dependent on what our item that we're going to test, the gender. If you're gonna get someone and they're males, well, you got to use the male heights, right? If it's female, of course, you got to use the female heights, right? All right, so depending on what you are going to calculate z-score, that's going to be dependent on the gender. So on the formula, the x term on our numerator is going to be the measurement that we're going to test to see where they fall on our scale. There's your mean. You substitute the mean, you substitute the standard deviation that's given. So we need to figure out whose height we're going to observe to see where they fall on the scale. So let's say, in my case, so Mr. Guerra, height. I am 6 foot on the dot. Okay. I'm 6 foot. And I want to see what my z-score is where I fall on the scale. I want to know where I'm going to be at. Am I gonna be usual, or I'm gonna play for the NBA, or am I gonna be in the circus? You don't know. All right, so let's see. The problem is that my height is recorded in feet. So what I have to do first as a researcher or nurse or doctor, I need to convert. I need to convert to centimeters. Okay, so how do I convert feet to centimeters? Well, I do know how to convert feet to inches, so I'm going to convert my feet to inches. So what I do is I multiply, right? I'm going to multiply 6 feet times 12 inches, right? 12 inches per 1 foot, right? So I know that my feet cancel out, and so that would give me 72 inches, right? So I converted to inches. Now I want to convert 72 inches. I want to convert it into centimeters. Well, the conversion for inches to centimeters is it's 2.54 centimeters per 1 inch. So because I have my units right across, I can cancel, multiply 72 times 2.54. My height is equivalent to 182.88 centimeters. And so now I have my height recorded in centimeters, just like my mean and my for the men's and the females. So now I can calculate the z-score. Okay, so I'm going to use the population one because these heights were from America. This is US standards. So I'm going to use z equals x minus mu over sigma. If you use the other one, it's going to be the same. So you don't have to worry. All right, so there's my height. So it's 182.88. And I'm going to subtract the mean height of men, which is 163.85. Right? And I'm going to divide that by my standard deviation of 6.35. I'm going to divide the whole thing by 6.35. And I get, let's plug it in, 182.88 minus 163.85 divided by 6.35. Why did I get a syntax error? I don't know. Okay, hold on 1 second. What did I do wrong? On my calculator, oh, I forgot to put this. All right. Wow, I got 2.996850394. If I round it, If I round it off to 2 places, it becomes 3.0. So my z-score is 3.0. So on my scale, 3.0 is right here. Here I am. Bam! There's Mr. G. Right there. I'm considered to be unusual. Ooh, I need to I'm gonna have to call the Spurs. Hey, I'm willing to play for 100,000 a year. I'm good with that. I'll be the ball boy. I don't mind. Excellent. And so that's how it works. You get your z-score and you plot it on your graph to see whether or not you're considered usual or unusual. Okay. Now, again, you will have to do some conversion if you're going into the nursing field. So you will have to convert feet to inches and just do centimeters, but that's the procedure and how to do that. Okay. Now, in the book, there are 2 individuals. We can do a problem in the book. And this is on page 125. On page 125, we're going to do problem number 13. So there's 2 individuals. And this book was written back in 2005. And so at that time, there were 2 individuals that had a peculiar height. Okay, so let's look at it. So we'll go to page 125. And there's number 13. Okay, so the tallest living man at that time of this writing is Sultan Kosin, who had a height of 251 centimeters. The shortest living man, his name was Chandra Bahadur Dangi, who had a height of 54.6 centimeters. Heights of men during that time was 100. The mean was 174.12 centimeters, and they also had a standard deviation back then of 7.10. Now this is world. This is from the world. This is not from any particular country like U.S. This is the world. They want to know which of those 2 men had the height that is more extreme. How far away from the center did one of them have the furthest? That's what they want to know. So in other words, they want you to compute the z-score for both of them, and they want you to figure out which one was relatively far from the center of 0. All right, so let me write down. We're going to write down the mean. So they told us that the mean is 174.12 centimeters, right? And the standard deviation, the O, was 7.10 centimeters. So I'm going to write down, we're going to do Kosin. All right, and then we have Chandra. All right, Kosin had a height of 251 centimeters. 251 centimeters. And Chandra had a height of 107. No, he had 54.6. 54.6 centimeters. 54.6 centimeters. You can look it up. You can look at both of them. There's a picture. If you Google, there's a picture of both of them standing side by side next to each other. It's amazing, amazing. Look it up. It should be on there. You Google it. Okay, so we want to know who is relatively far away from them. All right, so we're going to compute the z-score for Kosin, and then we got to compute the z-score for Chandra. So let's do Kosin. So z equals x minus mu over sigma. All right, so we're using Kosin. So Kosin, we don't have to convert. Everything's already in place. They're already in centimeters, so we're good. We don't have to convert. We just simply just plug it in. So 251 minus 174.12. And then we're going to divide by 710. And let's see what we get for Kosin. So 251 minus 174.12 and divided by 7.10. I forgot to put the parentheses. Hold on 1 second. Kosin z-score is 10.83. Okay, that's Kosin. Okay, Chandra, let's compute his z-score. So his, let's see, x minus mu over sigma. We're going to substitute 54.6 minus 174.12. And we're going to divide that by, I should have put that in red, by 710, because that's what was given to us, right? Those two were given to us. 710. I'm going to put in my calculator. 4.6 minus 174.12 divided by 7.10. His ends up being negative 16.83. So on the scale, who is further away from 0? Kosin or Chandra? All right, here's 0. So I'm gonna have to really 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very close to 11, right? So there is Kosin. I'm gonna just put K for Kosin. He's way over here. And Chandra, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, 13. All right, I think he is way over here, Chandra. So Chandra he is further away from the mean. Negative 16, way over there, way over there. So yeah, he was relatively small compared to the whole entire population of the world. He was he had a very unusual height, more so than Kosin. Now you guys are probably wondering, well, where's Shaq? Where is Shaq? Where is Boban? Where is Yao Ming? Where would they be at? Well, you'd be surprised. They are somewhere over here. I think Shaq was 8. 1, 2, 3, 4, 5, 6. He would be right. I think Shaq was about right there, 8, compared to Kosin. He was really much taller than Shaq. Oh, and Boban and Yao Ming. He was super tall. That's where Shaq would be at. He was 8. Be a little baby for Kosin, man. Amazing. And that's probably because of the pituitary gland that affected their heights. And you can look at the parents. The parents were like normal beings. Their heights were perfect, but for some reason the pituitary gland just was enhanced. I don't know. Right. So that's how the z-score works. So you're going to be given a value that you're going to compare, and you base that off of the mean standard deviation. You plug them in. There's 3 numbers. There's 3 spots. Plug it in. Compute it. Round to 2 decimal places. and then plot it and see again the cutoff scores was at +2, -2, right? There's our usual. This is our teeny weeny little usual. And you can see that they are definitely in the unusual. So one of my students asked me, sir, so what does not unusual mean? Good question. Not unusual is kind of like if you have a -4, what happens to the two negatives? It becomes a positive, right? So not unusual equates to be usual. So anytime you guys see not unusual, just like the Tom Jones reference to the song, it's not unusual, that means it is usual. In case you ever come across it, just let you know. Let you know. Okay, so there's your z-score. All right. And the next topic we're going to cover are called percentiles. All right, so percentiles, usually you see percentiles when you take standardized exams. Have you ever taken a SAT, ACT exam and you take the exam, right? And and then later on, they give you the results back. They give you a whole envelope with a whole bunch of papers. And you get it back and you're like, well, yeah, how do you read it? Like, what does that tell you? Well, when you take standardized tests, you are being compared to all the other students that took the test. And they rank y'all. They want to see where you rank in comparison to the other students that took the test. That's what percentiles measure. So you want to be in the top percentile. And it's kind of like when you were ranked in high school, right? When you were ranked in high school, you had, you know, the top 10%, right? The top 10%, the second top 10%. So in ranking in high school, also you are creating a percentile. So that's what percentiles are. You're being ranked, and you're figuring out where you stand in the terms of the ranks, where you did well or you did poorly. That's what percentiles are. So let me give you the definition of it, of percentiles. And percentiles are measures of locations denoted by P sub 1. There's a little 1 or P sub 2 all the way down to P99, which divide a set of data into groups. It doesn't have to necessarily be 100 groups, but it has about 1% of the values of each group. So you're grouped, just like ranking. You were ranked from high GPA to the lowest, and they group them, and they call the groups whatever. Like there's your top 10%, from the highest GPA down to the lowest, which we don't know what happens to the people who rank last. They probably are in the politics or something. I don't know. So percentiles are measures of location, and it's denoted by P, and then on the bottom you have a 1, P1, P sub 2, P whatever, it goes up to P99. There's no such thing as P100, which divide a set of data into groups. I'm not going to say 100, but you divide it into groups with about 1% of the values in each group. Okay. That's what percentiles are. Now, there's going to be some formulas that we're going to be using to find the percentile of a data value on a list. So one of the things you're going to have to do is you're going to be given a list. Okay, you'll be given a list, and what you'll have to do first and foremost is you will have to put them in order. Given a list of data, data must be arranged from smallest to largest. Okay. So it's gonna be kind of like a kind of like a board game. If you ever play a board game and you roll a pair of dice, right? You roll a pair of dice, and whatever the face values are, you have to add them up, right? So kind of like I have some dice, right? So when you guys played board games, right? You roll the dice. Oh, 5, right? So you know you got your piece and you went 5 spaces, right? You started 1, 2, 3, 4, 5. That's how the process is going to work. Kind of like rolling the dice and moving your piece along the table. That's how it's going to work, right? So I'm going to give you the formula, and we're going to do first. I'm going to show you first how to find. So finding the percentile of a data value given. Okay, that's the first thing I'm going to show you. And there's a formula that you're going to use. Here is the famous formula. Okay, so I'm going to write it down. So percentile of value X is going to equal to, on the top, you're going to have the number of values less than X divided by the total number of values, and the whole thing is going to be multiplied by 100. That's the formula. And it also says here, you can see it at the top, it says round the result to the nearest whole number. Round answer to the nearest whole number. Very important. All right, so let's use, there's a data set below here. This box here, table 3.4, is a list of sorted Verizon airport data speeds. So they were measuring data speeds at the airport. And as you can see here, they are giving you the data in rows. Notice that the data are in order, row by row, from top row to bottom. So they're already sorted for you, okay? All right, so if I'm asked to find a percentile, and we just pick a number, you have to pick a number that's within the data set box. It's got to be a number. So let's say we chose data 13.7, and I want to find the percentile of value 13.7. Okay, so if I use a formula, it says how many numbers are less than 13.7. So you're gonna have to count. Here's 13.7. How many numbers are smaller than 13.7? So you're gonna have to count backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There are 24 numbers that are smaller than 13.7. So that's what the top number is. So the top number is the number of values less than 13.7. There were 24 numbers, right? And I'm going to divide that number by the total number of data that are in that box. So let's count them. I believe there are 5 rows, and each row has 10. So that means that there are 50. So it would be 24 over 50 times 100. Now, again, what is it? Where am I getting that 24? 24 are the number of numbers that are smaller than this 13.7. You have to count backwards. How many numbers are smaller than 13.7? That's what this top number is. That's right here. Number of values less than X. You want to count the number of numbers that are smaller than. So I get 24. And I'm going to divide that by 50. And I'm going to multiply by 100. So let's take my calculator. 24 divided by 50. Multiply by 100. I get 48. So to write it as a percentile, you're going to write it as P subscript 48. That's your percentile. P48. Okay. Let's do another one. We'll do several of them so you can get the feel for it. All right, so let's pick another number on the list. It's got to be a number on the list. You cannot pick another number other than the numbers on the list. Let's find the percentile of, let's see, value. What do we pick? Let's do value 22.4, right? All right, so let's find the percentile of value 22.4. Sorry, 22.2. All right, so count how many numbers are before 22.2. Let's count them. So I know I need to count all these numbers because they are before 22.2, right? So how many numbers? I believe that's 30, 31, 32, 33, 34, 35, 36, 37. There's 38. There are 38 numbers before 22.2. So that would be 38. I'm going to divide by 50, which is the total amount of numbers in my box. And I'm going to multiply by 100. All right, so let's do it. So 38 divided by 50. 38 divided by 50 times 100 gives me 76. So we write it as P76. There's my answer. Okay. All right, let's do another one. Let's find percentile of a number that repeats. I have a number on the chart where it repeats. Duplicates. What do you do when you have duplicates? All right, so let's look. Which one has a duplicate? Look at that one. We have 11.1. Let's find the percentile of 11.1. Notice that it repeats. So does 4.5. Right? So let's find the percentile of 11.1. All right. So what you do is you locate the very first time that 11.1 appears. If you start from smallest and you gradually go up, the first time it appears, boom, right there. You're going to use that one as a reference. Don't use the second one. You want to use the very first time from smallest to largest that 11.1 appears. So how many numbers are before 11.1? Let's count them. How many are before? 10, 11, 10, 11, 12, 13, 14, 15, 16. There are 17. There are 17 numbers before the first 11.1 appears. So I'm going to do 17 divided by 50, and I'm going to multiply by 1. You can count the blue. The blue that I have highlighted are the numbers that you got to count because it's smaller than 11.1. Right, and so I record it. I'm going to divide. And so let's see, 17 divided by 50. Multiply that by 100. I get 34. 34. So 34. So this would be P 34. All right, and the last one. Let's find the percentile of the very last number that appears on our table. What was the very last number that appeared? Oh, 77.8. What is the percentile of 77.8? All right, well, how many numbers appear before 77.8? Well, there's 50 of them. There has to be 49. So 49 over 50, right? And then we multiply that times 100. Right? 49, there's 49 numbers. So 49 divided by 50. Times 100 gives me 98. So this records as P 98. So you got to remember, you got the total number of data in the list is 50. This top number represents the numbers that are smaller than this number that's on the list that are put in order, and then multiply by 100. So on the test, you guys don't refer to it as page 98. It's not page 98. It's a percentile. Percentile 98. That's how it works. All right, so that's how you find the percentile of a data value given. Now we're going to go backwards. What if we're given the percentile? We want to trace it back to the number that's on the list. So I'm going to show you how to do it backwards. So let's go back to our book and let's look for it. So this one is called, do I have it here? Converting a percentile to a data value. So that's what we're going to do next. We're going to go backwards. Okay, so let me write it down. Converting a percentile to a data value. All right, so little background. There is a flowchart that you will be using. It is on page 116. You want to follow it. Follow the flowchart. I'm gonna kind of summarize it a little bit better than the flowchart, because the flowchart's kind of hard to understand. So I'll share with you my secrets. All right, so notation. So we're going to use n to represent the total number of values in the data set. we're going to use a lowercase k to represent the percentile. So 25th percentile, k is 25. L represents the locator. That locator, capital L, gives the position of a value. So just like I told you, when you roll your dice, whatever face value is, you sum them up, you got to move your chest, your piece, right? You're going to be moving your piece. That's what that L is. You're going to be moving along until it tells you where to stop. That's the locator. The number that's the L will tell you where to stop. So if L is 12, you're going to move 12 spaces, beginning with the very first number that appears, the smallest number that appears on the list. You're going to count 12 numbers down, or whatever that L value is. That's where you start counting spaces. And then PK, as you recall, that represents the K percentile. Okay. All right. So let's follow the flow chart. All right. So you start there, right? The first thing you do is you want to sort the data from smallest to largest. We already know that. So step 1, put data in order from small to large. Right? All right, step 2. You are going to compute this formula. So you're going to compute the L, the locator number. So the formula is L equals K, parentheses, K over 100 times N. So K represents the percentile, and N is the number of values, the total number of values. So put K is the percentile. You don't have to change it to decimal. It's just whatever the number is. And N is the total number of values. Right? Okay, you compute it. You can compute your L. And then this is where it gets confusing. All right, so there's going to be two roads to take. All right, so for step 3, if your L value that you compute, the formula that you compute, if it ends up being a whole number, if L is a whole number, okay, you are going to count starting at the lowest value on the list, L spaces, and get that value and find the average of that value and the one after it. So let me share my screen so you guys can write it. So, all right, so this is what you do. So if L is a whole number, you're gonna count starting at the lowest value on the list, on list, L spaces, and get that value and find the average of that value and the one right after it. So think of it like the median. Remember when we did the median and you had 2 middle numbers? What did you do when you had 2 middle numbers when you had a median? Well, you have to take the average of those 2 numbers, right? You add them, divide by 2. You're going to go L plus after L divide by 2. L plus after L divided by 2. That's the formula. L plus after L divided by 2. I think that covers 2 plus L plus after L divided by 2. Okay, that's if L is a whole number. Okay. Or if L is a decimal value, you're going to round up. You're going to round the value up. You're going to break the rules of rounding. If you have a decimal value like 13.1, you're going to bump it up to 14. Round the value up. Then starting at the lowest value on the list, count L values. Where you land is the answer. Will be the answer. Okay, so if it's a decimal number, you're going to round it up. Round it up. 13.1 becomes 14. 12.5 becomes 13. 11.3 becomes 12. You're going to round it up. Regardless of what's behind the decimal, you're going to round it up. Right? And then once you round it up, then you start counting that many number of spaces that you got for the, that's your new L. You're going to count spaces. If it's 12, you're going to count spaces. 12 spaces starting from the lowest number, you're going to count 12 spaces, and then where you land, that's going to be your answer. All right, so I got to do an example. I'll do 3 examples of these and then 3 examples of the B, so you can get an idea. Hopefully the numbers that I choose will work. We'll see. All right, so let's go back and look at the data that we had before with the Verizon data. We're going to look at that again. Okay. All right, so let's do an example. So let's say, I think there were 60 numbers. All right, let me see. Hold on. So hold on, 23. Okay. So let's do as an example. Find P. What did I put? P24. All right, P24. And we're going to use the data for the Verizon. See if I can find it. We're going to use this table right there. Okay, we're going to use that table. All right, so P24. All right, so here's the formula. So I already have the data in order. So I'm going to do L equals K over 100 times N. All right, your K is at 24. This is what your 24 is. That's your K number. So you're going to do 24 over 100. And your N was the total amount of data that was on that box. There were 50 of them. There were 50. All right, so calculate it. You can use parentheses or not. Let's compute it. 24 over 100 times 50. I get an L value of 12. Okay, now 12 is a whole number. Okay, 12 is a whole number. So it tells me I'm gonna count 12 spaces. Okay, I'm gonna count 12 spaces. And where I land, I'm gonna get that number and I'm gonna take the average of that number, the one right after it. So let's count. Don't use the 12. You're going to count 12 spaces. All right. So let's go to our list. And I'm going to count starting at the beginning. I'm going to count 12 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. It's 7.7. So I'm going to take 7.7 and the 7.9. And I'm going to take the average of those two numbers. That's my 12th number. I'm going to get the 12th number, which is 7.7. And I'm going to add to it the next number, which is 7.9. And I'm going to divide by 2. So if I add and divide, I end up getting 7.8. That was the 12th value on the list. The one after it is the 7.9. This was the 12th. Let me write it down here. This was the 12th value. And the 79 was the one after it. Okay. That's how it works. Right? Let's do another one. Let's find, let me think. Let's find, okay, let's find P12. P12. And we use the same data value, same data. All right, so I'm going to do my L. So L is K over 100 times N. So that would be 12. That's my 12 divided by 100. And there are 50 numbers. Right? So I calculate it. 12 over 100 times 50 gives me 6. Right? It gave me 6 when I computed it. All right, 6. All right, so 6 is the whole number. So I'm going to count 6 spaces. I'm going to get that value that I land on the 6th value, and then I'm going to get the one after it. I'm going to take the average of the two. So there's my, I'm going to find the 6th value. I'm going to find the number, plug it in there, and then I'm going to get the number after it, and I'm going to add those two numbers up and divide by 2. So let's count. I got to count 6 spaces, beginning at the beginning of the chart table. I'm going to count 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 3.6. So it's 3.6 plus the number right after 3.6 is 4.5. And I'm going to divide by 2. I'm taking the average of the 6th value and the one right after it. Right. 3.6, that's the 6th value in the list, and the one right after it is 4.5. So I'm going to add them. Divide by 2, 4.05. You don't round that number, that's it. It is 4.05. Notice each time that I use my L, I ended up getting a whole number. I'm going to put it here. This is a whole number. The whole number. Right? The other one, we had a whole number too. Right? We got a whole number for my L. Whole number. We got a 6 whole number. All right, we're going to do one more. Let's do one more whole number. Let's do P. We'll do P 60. Let's see, 66. Yeah, let's do P 66. Find P 66. All right, here we go. So we got to do L equals K over 100 times N. We substitute. There's my K is 66. 66 divided by 100. And we multiply it times 50. When I calculate it, I get 33. 33 is a whole number. Again, it's a whole number. So I'm going to go back to my formulas and see what did it say that I had to do when I got a whole number. I got to count 33 spaces. Right, I got to count 33 spaces. Okay, let's go to my table. I'm going to take the average of that number that I land on the 33 spot, and then take the average of that one and the one right after it. It's a whole number. All right, so let's count 33 spaces. 10, 20, 30, 31, 32, 33, 16. All right, so I'm going to take the average of the 16. So the 33rd value on the list is 16.0. And I'm going to add to it the next number, which is 15.5. Sorry, 17.5. 17.5. And I'm going to divide it by 2. So I get 16.275. 16.75. Yeah, 16.75 is my answer. So all of these examples, our L value ended up giving us whole numbers. So that's why I keep using the first scenario for step 3. Whenever you have a whole number, you got to do this average business. That's supposed to be L plus after. My A is not next, yeah, after L, right? So now let's do examples where the L value comes up to be a decimal. What do? It comes up to decimal. All right, so let's see one. So let's find P23. P23. All right, so here we go. So L equals K over 100 times N. So my K is 23. So 23 over 100 times 50, because 50, I had the whole 50 numbers on my list, and I'm going to compute it. 23 over 100 times 50, I get 11.5. Right? This is a decimal. Right? It's a decimal number, which tells me I have to round up. So I'm going to round it up, and that gives me 12. So I'm going to count 12 spaces from the list. Where you land, that's going to be your answer. So let's go to my list and I'm going to count 12 spaces. That's all you do. You just count 12 spaces. So here we go. That's 10, 11, 12. My answer is 7.7. The end. That's all you do. You don't have to take the average. You just count 12 spaces. You've already rounded it up. You just count 12 spaces. Bam. That's where you land. Yep. All right. We'll do another one. Let's do, I'm trying to think. Hold on. Still thinking of a number. Let's do find P79. P79. Let's find P79. All right, so here we go. L equals K over 100 times N. So 79 over 100 times 50. So I'm going to calculate it in my calculator. 79 over 100 times 50 is 39.5. Notice that my L value came out to decimal. It came out to be 39.5. It's a decimal. So I have to bump it up. So that becomes 40. You're going to count 40 spaces. Where you land, that's your answer. Here we go. 10, 20, 30, 40. Yeah, 40. My answer is 22.4. That is the 40th value on the list. 22.4. Boom. Done. Okay. Each time I keep getting the decimal, I gotta bump it up. Again, even if this number had if you have a value other than 0 after the decimal, whether it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you're gonna bump up that number regardless. You're gonna, if it's 5 or less or 5 or more, it doesn't matter. You're gonna bump it up. If this had read 39.1, you're gonna bump it up. You just bump it up. Even 39.2, you bump it up to 40. 39.3, you bump it up to 40. Any number other than 0, you're gonna bump it up. Bump it up. All right, one more. Let's find P, I don't know, P91. P91, I don't know. All right, so we're gonna do L equals K over 100 times N. By now you probably memorized it already. 91 over 100 times 50. 50 is the total number of data in that box. Calculate it. Calculate it. 91 over 100 times 50. I get 45.5. Again, it's a decimal number. I gotta bump it up, which equates to 46. I'm gonna count 46 spaces. Where you land, that'll be your answer. You're gonna count 46 spaces. Here we go. 1, that's 10, 11, that's 21, 40, I need to go to 46, 41, 42, 43, 44, 45, 46. There it is. Value 38.5. There it is. And you're done. Right there. There's your value, 38.5. That's the 46th value on the list. There you go. So you're probably gonna need this here for your test to distinguish between which is which, right? Or you all can use the flowchart. Either one, it's the same thing. It's just that mine is written in English. This one's written in, I don't know, some sort of language. But either one we can use. Okay. All right. So that's how you go about converting a percentile to a data value. All right. So the next thing I'm going to show you is quartiles. Okay. So let's look at quartiles. So quartiles. Let me get quartiles. Quartiles are measures of location denoted by Q1, Q2, and Q3, which divide a set of data into 4 groups with about 25% of values in each group. Let me write this down because you're going to tell me that doesn't make any sense at all. All right, so quartiles divide the data set or data set into 4 groups with about 25% of the values in each group. Okay, so you have Q1, Q2, and Q3. You're like, wait a minute. That doesn't make sense. How shouldn't there be a Q4? No, there is no Q4. That is correct. It's correct because you have a group before Q1, that's the first group. You have a group in between, that's the second group. You have another group in between, that's the third group. And then you have a group right after Q3. So these 3 values cut off and form your 4 groups. 1, 2, 3, 4. They're like cutoffs. There's where your 4 groups come into play. All right, so there isn't really much. There's really much you can do for these because these Qs are conversions. You can convert those into percentiles. So Q1, Q2, Q3 can be converted into percentiles. So Q1 is really P25. They're breaking them up into quarters. So Q1 is P25. Remember, we're thinking quarters. Q2 is what? If you have another quarter, 50 cents. And Q3 is P75. So those are the conversions. So anytime that you all see Q1, you rewrite it as P25. If you see Q2, it's P50. If you see Q3, that is equivalent to P75. So let's do an example. So using the data from the Verizon, if we're asked to find Q2. All right, so Q2 is really P75. So I'm going to use the rules for finding P75. As you recall, what we just did it a while ago. You got to find the L. So L is K over 100 times N. My K is 75. I'm going to divide it by 100. Because I'm using the data for the Verizon, multiplied by 50. I'm going to calculate it. 75 over 100 times 50 gave me 37.5. I have to bump it up. I'm going to look up the 38. I'm going to count 38 values. Spaces, right? Where you land, that's going to be our answer. Let's count. 38 spaces. All right, let me see if I can find my data. Where did I lost my data? Where is my data? There it is. I'm going to count 38 spaces. Let's see. That's 21. I need 38. 30, 31, 32, 33, 34, 35, 36, 37, 38. Value 21.5. Bam. So all you're basically doing is converting the quartiles into a percentile. And so there you go. So notice Q2 equates to P50. And sorry, did I do that wrong? That should have been Q3. Sorry. Q3, my bad. I said did I say Q2? Yeah, I did say Q2. Sorry, I meant Q3. Q3 is P75. Yeah, there you go. Q3 is P75. Yeah, if I want to do Q2, then I would do 50 over 100 times 50. You're gonna get a decimal, and you have to bump it up. So sorry, that was Q3, not Q2. Q3 is P75, and that's all you do. You just change it to a percentile and just do what we did before. Use the flow chart or use my notes. You're good. All right, so we got quartiles. And the last thing we're going to do is what we call a box plot. So another way to graph data to show bell-shaped or skewed is by graphing a box plot. They also refer to it as a box and whisker, I believe. I think that's what we call it. Box and whisker. There you go. Yeah, box and whisker. It's a graph of a data set that consists of lines extending from the minimum, maximum value, and a box with lines drawn at the first quartile, the median, and the third quartile. You're like, huh? All right. So what is required? Requirements. So requirements, you need the minimum value. You need Q1, which Q1 was P25. You also need Q2, which was P50, and you need Q3, which is P75, and then you need your max value. So you need to have 5 values to graph. These are the 5 things that you need. Minimum value, you need the P25, Q1, Q2, Q3, and the max, right? So let me show you what a graph of it looks like. So if you want to know if whether or not the data is bell-shaped, this is what the box plot will look like. Now you gotta use your imagination. You really gotta use your imagination and you tell me what it looks like. All right, what does it look like? That is correct. Someone said it looks like a TIE fighter from Star Wars. Exactly. That's what a TIE fighter looks like. It's bell-shaped. This box in the middle has to be a perfect square. It's got to be a perfectly drawn square. And it's got to be smack in the middle. This line is your Q1. Sorry. No. That line is your minimum. Sorry, this is your minimum value. That's what that line is. Your Q1 is going to be the left edge. That's your Q1. The middle is your Q2. And the right edge of the box is your Q3. And the far right line is your max value. That has to be a TIE fighter. Other than that, everything else is skewed. So this would constitute a skewed one. Notice that the shape of the box is rectangular and is really close to the edge. This one, we say that this one's skewed to the left because the tail end is on the left side. Same thing, min, max, Q1, Q2, Q3. Right. So you're gonna be drawing these, but you're gonna let Excel, I'm sorry, you're gonna let StatDisk, not Excel, you're gonna let StatDisk do the job for you. So I'm going to show you all how you can have StatDisk draw your box plot. Okay, the box plot. Say that 5 times. All right, so let's look at the StatDisk, and we're going to do an example. All right, I don't think I have it here. StatDisk. Okay, here's my StatDisk. All right, so let me load up a data file. So I'm gonna bring up a data. So we will do body data. And let's look at the BMI. Yeah, we'll do BMI. Let's do BMI. Let's do a box plot for BMI. All right, so either you load up the data, you type them in one column, or you bring it up. All right, it doesn't matter. All right, but I want to do a box plot for the BMI. All right, so here's what you do. You got your data sets up. You're gonna click on data. You're gonna click on box plot. Okay, and you're gonna pick which column did you want to do a box plot on. I want to do a box plot on my BMI, and I'm going to hit box plot. Bam, there is your box plot. This one's definitely skewed to the right. Notice that it gave you the 5 numbers. There's your minimum, your Q1, your Q2 is your median. It's letting you know. Q2 is the median, Q3, and then there's your max. You guys can download it. If you click on that Google camera, you can download it, copy it, paste it in a Word document, along with your other graphs. That's how simple it is. Yeah. All right, you want to do one from scratch? We can do one from the exercises. So let's go back to our book. And let me see if I can share it with you, my book. And maybe we can do, let's do one of the ones from your homework. Yeah, let's do speed dating. Speed dating. What is speed dating? What the heck is it? Anyways, I don't know anything about that. I just know about farmers only. That's all I know. Anyways, all right. So there's my speed dating data. Oh, I need to type it in. I need to write down the numbers. 2.0, 3.0, 4.0, 5, 6, 6. How many sevens are there? 1, 2, 4, 6, 7, 6. How many eights? There are 5 8, 4 eights, 4 eights, a 9, a 9.5, and 2 10s. Okay, here we go. I'm gonna type them in. I'm gonna do number 29. I want to create a box plot. All right, so here we go. I'm gonna go to my set disk. Let me clear this. Clear my table. I can't get it. What? Clear. Yes, yes, yes. Clear. All right. I'm typing them in. So 2.0. I'm not going to put 2.0. 3, 4, 5, 2 6s, 2, 4, 6 7s, 1, 2, 3, 4, 5, 6 7s, 4 8s, 1, 2, 3, 4 8s, a 9, a 9.5, a 10, and a 10. That should be 21. All right, I typed the numbers in. I'm ready to go to data. Click on box plot. I typed in my data in column 1. This one doesn't have a label, so I typed them all in column 1, and I hit box plot, and presto, there's my graph. This one is skewed left. And again, you can copy it. If you don't believe me, hit the camera, download it. You can paste it on your Word document with all your other graphs.